Hello, welcome. Let's try to solve another Leetcode problem. 775 global and local inversions. So we have two definitions. So one is global inversions. So let me give you an example. Let's try to use the second example. So the global inversion is that the first number, so for example from the left to the right, the first number is more than all other numbers. So for example, this one is more than 0, this is one global inversion count, and 2 is more than 0, it is another inversion count. And the local inversion is that there's only one count. So for example, 2 is next to 0, so there's only one count, but 1 to 0, we will not count it because that is global inversion, but not local inversion. Yeah, so for 1 and 0, it is only a global inversion, but not a local inversion. So in this problem, we can, so for 1 to 0, we can think reversely. So if this is a local inversion, definitely it is a global inversion, right? So in mathematics, if this is a local inversion by the definition, so if this is 2 and 0, for 2 and 0, this is a local inversion. Definitely this is a global inversion, right? But if this is a global inversion, is that definitely a local inversion? No. Sometimes it is, but sometimes it's not. So for example, this 1 and 0. It is a global inversion, right? Because 1 is more than 0. But it is not local inversion because 1 is not next to 0. Yeah. For sometimes, for example, 1, 0. So this is both a global inversion and a local inversion. Yeah, but sometimes for this 1 and 0, the distance is 2. So it is a global inversion, but it's not a local inversion. Yeah, so what are we gonna do? We're gonna solve this problem by the reverse seeking. We're gonna check the distance. So if the distance for two numbers that is more than and equal to 2 or more than 1, if the distance is more than 1, if the distance of two numbers is more than 1, and it is a global inversion, definitely this 1 and 0 is not a local inversion because this 1 and 0 will count to the global inversion but will not count to the local inversion. So for local inversion it's gonna still be 0, but for global inversion it's gonna be 1. Yeah, so we're gonna solve it by in this way. And basically we need to use a one loop to solve the problem. It means O(n) time complexity. So how can we solve it in O(n)? So for example, we have an array of numbers. So from here, in these areas, we're gonna record the maximum numbers, and here is a distance of 1. We're gonna keep 1 numbers, yeah. And from here, from these areas, we're gonna check this number. It's this number, yeah. It's this number. For example, this number is 5. So if this number 5 is less than the maximum of these areas, so before this empty number, maybe the maximum of this area is 6. If it is less than, so it is a global count, definitely, because here is another number, but we are checking the number just before this empty number. Yeah, this black area just before it. Yeah, so if my count number is less than the previous maximum number, definitely it is global inversion, but it's not a local inversion, so we're gonna return false. Otherwise, we're gonna return true. So for the next step, we're gonna shift it to one step here, and this is empty, and this is my current number here. Yeah, so my current number, this number, gonna compare with the previous number. I mean the number even before this one. Yeah, maybe this is 6, and this is 5, and maybe this is 7, and we find another one, so we're gonna return a false. Yeah. So let's try to solve it in this way. I hope you understand it. So we're gonna prepare a variable n, and it's gonna be the length of the nums, and we're gonna prepare a previous maximum number, and it's gonna be nums 0. Now what are we gonna do? We're gonna check the third number, because the second number is a neighbor. We will check neighbor. We will check number which is not the neighbor of the maximum number. So currently the maximum number is the first number. So I'm gonna check from the third number to n. Yeah, I'm gonna check if my current number is less than the maximum number. Definitely I'm gonna return a false. Yeah, Otherwise, I'm gonna update the maximum number. It's gonna be the maximum of maximum with nums I minus 1. Yeah. Because currently this is the index 2, but for the next step, yeah. So currently, I compared with this maximum, so they are not neighbors. Yeah. And after that, I'm gonna plus this nums I minus 1, because I can shift to one position, and then my I will go to the index 3. So in this way, I will always check the numbers which is not neighbor. Yeah. And finally, we can return true if we didn't find a false. Yeah. So the coding is not so difficult. I think it's really difficult to understand the principle. What is the local inversions and what is global inversions? As you can see, the time complexity is O(n). So the global inversions must be a local inversion. Yeah, but so the local inversions must be a global inversion, but the global inversions cannot be a local inversion. So we have to understand it like that way, and then we can solve the problem. Thank you for watching. See you next time.